So let's take a look at limits at infinity and horizontal asymptotes. Now, limits to infinity is another way of saying end behavior. In other words, what y value does the function approach as the x value increases without bound? Now, when it comes to end behavior of functions that are fractions, there are three main types of scenarios. Now, the first scenario is when you have the limit to, or the limit as x approaches infinity or negative infinity of some fraction that is bottom heavy. So in this case, it would be something like x cubed plus 4 over x to the fifth. And what I mean by bottom heavy is where the highest degree of the numerator, which is x cubed, is less than the highest degree of the denominator, which is x to the fifth. So obviously 3 is less than 5, so this is a bottom heavy fraction. Now the limit to infinity or negative infinity of a bottom heavy fraction is always going to be equal to 0. That's basically the easiest one. Now the second scenario is going to be the limit to infinity or negative infinity of a top heavy fraction. So in this case, let's say we switch the roles, so we have x to the fifth on top, and then we have over x cubed plus 4. In this case, the highest degree of the numerator is greater than the highest degree of the denominator, because 5 is obviously greater than 3. So in this case, in order to find the limit to infinity or negative infinity, we basically take the highest degree of the numerator, highest degree of the denominator, and divide it out. So x to the fifth, we divide that by x cubed, and then we get x squared. And then if the limit is to infinity, you'll plug in infinity for x, and if the limit is to negative infinity, you'll also plug in negative infinity for x, but regardless, since it's squared, it's going to be positive, and so infinity squared is still going to remain as infinity, negative infinity squared is still going to remain as positive infinity. And so the third scenario now is where it's not top heavy nor bottom heavy, but it's equal. So let's say we have x cubed plus 4 over x cubed. In this case, the highest degree of the numerator is equal to the highest degree of the denominator. So all we have to do in this case, when the limit is to infinity or negative infinity, is to take the ratio of the coefficients of the highest degrees of the numerator and denominator. So the coefficient of the highest degree of the numerator, x cubed, is 1. Obviously the coefficient of the highest degree of the denominator, which is also x cubed, is also 1. So all we have to do is take 1 divided by 1. And so in this case, the limit to infinity or negative infinity is going to be 1. Now another example of a bottom heavy function could also be something like 1 over x or 1 over x cubed, and so forth. So for number 1, we have the limit as x approaches infinity of 1 over 2x plus 3. Now 1 over 2x plus 3, as we've talked about before, is going to be a bottom heavy fraction, meaning the highest degree of the numerator, which is basically there's no degree, is going to be less than the highest degree of the denominator, which is going to be x to the first. So in a bottom heavy fraction, once again, the limit to infinity is going to be equal to 0. And another way to evaluate this, you can also think about plugging in infinity for x. So using direct substitution. If we have a very large number times 2, it's still going to be a very large number. Very large number plus 3 is still going to be a very large number. And then 1 over, or 1 divided by a very large number. Now think about 1 over 10,000. It's going to be 0.00001. Well, if we continue to increase that value, it's going to get closer and closer to 0. So 1 over infinity is basically equal to 0. So that's going to be the final answer. So now for number 2, we have the limit as x approaches negative infinity of 1 minus x squared over 2x squared minus 7. Once again, we're going to have to look at the highest degree of the numerator and denominator. So the highest degree of the numerator is going to be that negative x squared. Highest degree of the denominator is going to be 2x squared. Realize both of these have the same exact degree of 2. So all we have to do is take the ratio of the coefficients of the highest degrees. So once again, I'm just going to rewrite it as the highest degree is going to be negative x squared for the numerator. The highest degree for the denominator is going to be 2x squared. So all we have to do is take the coefficients, or the ratio of them. So we have negative 1 over 2. And so the limit to infinity, or in this case negative infinity, is going to be negative 1/2. So now for number 3, we have the limit as x approaches infinity of x cubed plus 5x over 2x cubed minus x squared plus 4. Once again, like all the other problems, we're going to look at the highest degree of the numerator and the highest degree of the denominator. The highest degree of the numerator is x cubed. The highest degree of the denominator is 2x cubed. Once again, they are the same degree of 3. So all we have to do is take the ratio of the coefficients. Once again, that is going to be equal to 1/2. And that's the final answer. So now for number 4, we have the limit as u approaches infinity of 4u to the 4th plus 5 over u squared minus 2 times 2u squared minus 1. So what I'm going to go ahead and do is actually FOIL the denominator. So we'll get 4u to the 4th, I'll just leave the numerator just like that, plus 5 over Now for the denominator, we get u squared times 2u squared, which is going to be 2u to the fourth. We have minus u squared, and then minus 4u squared, and then plus 2. Now I don't really need to worry about simplifying here because once again, like all the other problems, we're just looking at the highest degree of the numerator compared to the highest degree of the denominator. The highest degree of the numerator is 4u to the fourth. The highest degree of the denominator is 2u to the fourth. Because they have the same degrees of 4, we're just going to take the ratio of the coefficients of the highest degrees of the numerator and denominator. So 4 over 2 is just going to give us the limit of 2. So now for number 5, we have the limit as x approaches infinity of the square root of 9x to the 6th minus x over x cubed plus 1. So now the highest degree of the numerator is 9x to the 6th, but notice we're taking the square root of that. So the square root of 9x to the 6th is going to be 3x cubed. And then on the denominator, the highest degree is x cubed. Let's go ahead and write that down. Realize the degree of the highest degree of the numerator and denominator are the exact same, 3. So we're just going to take the ratio of the coefficients. So 3 over 1 is going to give us the limit of 3. So now for number 6, we have the limit as x approaches infinity of the square root of 9x squared plus x minus 3x. Now obviously this isn't in the form or in one of the forms that we talked about in the beginning of the video. So what I can do to get this into a fraction form is go ahead and multiply by the conjugate. So I'm going to rewrite our function here, square root of 9x squared plus x minus 3x. So in order to multiply by the conjugate, once again I'm going to multiply by the same thing. So we have 9x squared plus x. But instead of the minus separating the two terms, I'll have to multiply by plus. So square root of 9x squared plus x plus 3x over the exact same thing. So we have plus 3x. And so now I can go ahead and FOIL the terms and leave the denominator as it is. So in the numerator, we'll get square root of 9x squared plus x times the square root of 9x squared plus x. We'll just get rid of the square root, so there's going to be 9x squared plus x. And then we'll have negative 3x times 3x, which is going to be negative 9x squared. And then on the denominator, we'll just have the square root of 9x squared plus x, and then plus 3x. So realize the positive 9x squared and negative 9x squareds will cancel. And so rewriting, we have what's left is x over the square root of 9x squared plus x, and then plus 3x. So now I can simplify this even further by factoring out an x squared from inside of the square root. So I'm going to just focus on the square root right now and rewrite it as a square root. Once again, I'm going to factor out x squared, so x squared times 9 plus, when I factor out x squared from x, it's just going to be 1 over x. So now rewriting it, the square root of x squared is just x, so that can come outside of the radical. So rewriting, we have x over x times the square root of 9 plus 1 over x, and then plus 3x. Now realize that all the x's will cancel here. So what we have left is 1 over the square root of 9 plus 1 over x, and then plus 3. So now I can go ahead and rewrite the limit. So the limit as x approaches infinity of 1 over the square root of 9 plus 1 over x, and then plus 3. Now, given this fraction, it's kind of difficult to tell whether this is bottom heavy or top heavy because we have a fraction, we have a denominator, and in that denominator we have another fraction which we have to take the square root of. So the easiest way to go about this is to actually use direct substitution and directly plug in infinity for x. So when I do that, we get 1 over the square root of 9 plus 1 over infinity plus 3. Now 1 over infinity, remember 1 over a very large number gets closer and closer to 0. So we basically have 1 over the square root of 9 plus 0 plus 3. 9 plus 0 is 9, square root of 9 is 3. So then we have 1 over 3 plus 3, which is 6. And that is going to be the final answer for the limit. So now for number 7, we have the limit as x approaches infinity of just the square root of x. Now think about it as the square root of x over 1. So this tells us that the fraction is top heavy. So when it's top heavy, we just simplify as much as possible and then use direct substitution. Now square root of x can't necessarily be simplified any further, so we can just rewrite it as a square root of x. So when I use direct substitution, we basically get the square root of infinity, and the square root of infinity just remains as infinity. So that's going to be the final answer. Now another way to think about this limit is also by graphing y equals the square root of x. So if you graph it, it's obviously going to look something like this. And so as the x values increase without bound all the way to infinity, the y values will also increase to infinity without bound. So that's how we can tell that the limit is infinity. So now for number 8, we have the limit as x approaches negative infinity of x to the 4th plus x to the 5th. We obviously don't have a fraction here, but we can put it or rewrite it as x to the 4th plus x to the 5th over 1. And so it is top heavy. So the highest degree of the numerator is x to the 5th, and the highest degree of the denominator is basically 0. There's no degree. Or we can write it as just 1. So we can simplify it as x to the 5th over 1, which is obviously just going to be x to the 5th, and then we can go ahead and use direct substitution. So I plug in negative infinity for x, and negative number to the 5th power is going to remain as a negative number, so it's basically going to remain as negative infinity. Now the next set of problems are going to be about finding horizontal asymptotes and vertical asymptotes. So in order to find horizontal asymptotes, it's very similar to finding the limit to infinity or end behavior, similar to what we just did in the last couple problems. So for horizontal asymptotes, I'll just label it as HA. Let's say you have a bottom heavy function, so let's say 1 over x or something similar to that. Then the horizontal asymptote is going to be at y equals 0 since it's bottom heavy, similar to how the limit was also equal to 0 as well in a bottom heavy fraction. So now let's say you have the same degree on both the numerator and denominator, so let's say x cubed plus 2 over x cubed. It's the same thing as the limits, or finding the end behavior of the limits. All you have to do is take the ratio of the coefficients of the highest degrees. So we just take 1 over 1, so that's going to be equal to 1. So the horizontal asymptote is at y equals 1. Now, let's say you have a top-heavy fraction, or a top-heavy function like x to the 4th over x cubed plus 1. There's actually not going to be any horizontal asymptotes, but when you have a top-heavy function, it's actually known as a slant asymptote, not a horizontal asymptote. And we don't necessarily need to worry about that because, once again, with a top-heavy function, there are no horizontal asymptotes. And so now for vertical asymptotes, if I go ahead and label it as VA, all you have to do is go ahead and set the denominator equal to 0. And when you find those x values that make the denominator equal to 0, those x values are going to be where the vertical asymptotes are. So let's go ahead for these next set of problems, find the vertical and horizontal asymptotes of each curve. So for number 1, we have y equals x over x plus 4. So let's go ahead and start off with finding the horizontal asymptotes. Once again, with the horizontal asymptotes, we're just looking at the highest degree of the numerator and the highest degree of the denominator. The highest degree of the numerator is x to the 1st. Highest degree of the denominator is also x to the 1st. Because they are the same degree, we're just going to take the ratio of the coefficients. So that's just going to be 1 over 1, or the horizontal asymptote is going to be at y equals 1. Now for vertical asymptotes, all we have to do is set the denominator equal to 0. So I'm going to go ahead and set x plus 4 equal to 0. So then I'll just subtract over the 4. So at x equals negative 4, there is a vertical asymptote. So now for number 2, we have y equals x cubed over x squared plus 3x minus 10. Same thing here, let's just go ahead and start with finding the horizontal asymptotes. So the highest degree of the numerator is x cubed, highest degree of the denominator is x squared. Now if I go ahead and rewrite the highest degree of the numerator and denominator, x cubed over x squared, realize this is a top-heavy function, and in top-heavy functions, remember, there are no horizontal asymptotes, rather it's just a slant asymptote. I can also simplify x cubed over x squared down to x, and so x over 1, obviously that's still a top-heavy function. So the horizontal asymptotes, there are none. Now for vertical asymptotes, once again we're going to set the denominator equal to 0. So we have x squared plus 3x minus 10 equal to 0. Now I can go ahead and factor x squared plus 3x minus 10 into x minus 2 and x plus 5. So then the x values are going to be at x equals 2 and x equals negative 5. So we can go ahead and say at x equals 2 and at x equals negative 5, there are vertical asymptotes.